Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at arithmetic progressions as part of the A-level mathematics syllabus. So an arithmetic progression is one where you have a string of numbers and the difference between them is always the same. So in the first one the difference between the numbers is 4 and the initial number is 3. In the next one the difference between the numbers is 3 and the initial number is 3, so this is just a 3 times table. In the next one the difference is 5 and the initial number is minus 15. So you get some negative numbers and then you get to the 5 times table, and the last one the difference is 1. The first number is 1. This is just the counting numbers. So the counting numbers are an arithmetic progression, and we'll use that more a bit later on. We can also write these in terms of a general term. So for this one we write these are u1, u2, u3, u4, etc. and then we write un equals 3 plus 4 times n minus 1. So for instance the third term 11 is 3 plus 4 times 2. That is correct. This one, it's the first term 3 plus 3 times n minus 1, whereas 3 is the difference, and we can simplify this just to 3n, which shows this is just a 3 times table. This one is minus 15 plus 5 times n minus 1, and this one, un, is just n. So the 6th term is just 6, the 12th term is just 12. We can also write these as recurrence relations. So if we write them as recurrence relations, we can say un plus 1 equals un plus 4. So we take the previous term and we add 4, and then to do this we have to specify u1, the first term, and in this case it's 3. So here un plus 1 equals un plus 3, u1 equals 3. Here un plus 1 equals un plus 5, u1 equals minus 15. And here un plus 1 equals un plus 1, and u1 is 1. Okay, we also have a formula for the sum of an arithmetic progression. So if we have n terms in our progression and the first term is a and the difference is d, then the sum sigma equals n times a plus n times n minus 1 times d over 2, or n times a plus l over 2, where l is the last term. L is a plus n minus 1d. So there's this equation, or we can just say it's the average of the first and the last term times n, the number of terms. It's the number of terms times the average of the first and the last, which is a nice way to think about it. How do we prove this? Well, let's just look at the series a plus d, a plus 2d, etc., etc. So firstly, we've got n terms. Each one of them has got a single a. So we've got n lots of a. And then if we look at the number of d's, there's 1, 2, 3, 4, 5, 6, and it goes up to n minus 1. So it's all the numbers from 1 plus 2 plus 3 plus to n minus 1. And that sums to n minus 1 times n over 2. We can show why that is. We'll prove that on the next page. And then this immediately gives us our result, which is sigma, the sum, equals, sigma is just a algebraic way of saying the sum, is n lots of a plus d times n minus 2. That can't be right. n minus 2? No, n minus 1. Come on, we can correct this. n minus 1 over 2. Basically, it gives us the result because we've got d times n minus 1 n over 2 from here, and then the previous one is just n lots of a. And how do we know that the sum of all the numbers from, in this case, what we had is the sum of numbers from 1 to n minus 1 is n minus 1 n over 2. We're going to prove a similar result here, which is the sum of the numbers from 1 to n is n times n plus 1 over 2. So here's a really nice way of doing it. So firstly, the sum is just 1 plus 2 plus 3 plus dot 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 plus n. Or another way of thinking about it is n plus n minus 1 plus n minus 2 plus 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 down to 1. And if we add these two together, we get two lots of the sum. But 1 plus n is n plus 1. 2 plus n minus 1 is n plus 1. 3 plus n minus 2 is n plus 1. So we've actually got n lots of n plus 1. So 2s is n lots of n plus 1. So s is n plus 1 over 2, which proves our result. We can actually do this for the formula itself. So we could say sigma equals a plus d plus a plus 2d plus a plus 3d plus up to all the way up to plus a plus n minus 1d. Then we can have another sigma which turns that sum backwards. So we start with a plus n minus 1d. We add the 2, we get 2 lots of sigma equals n terms, and each of the terms is 2a plus n minus 1d when you actually work it out. So that tells you that sigma equals n lots of a plus n minus 1 n d over 2. I hope you like this video. Please subscribe and hit the notification bell. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.